Okay, class, today we are going to investigate when there is a change in the period of the function. So in these graphs, we're going to have an a value, which affects the amplitude, and a b value, which changes the period. So the standard sine function, which has the general shape looking like this, has a period of 2 pi, meaning this distance is 2 pi. And the standard cosine function that starts at its max and goes down to the midline, its min, and then back to its max, that has a period of 2 pi, which means these 5 dots, those key points, is a distance of 2 pi. Okay, so each graph is going to have our 5 key points, and the graph is going to start off with a period of 2 pi, but we're investigating the b, and when there is a b, it changes the period. So in fact, the period of a function is determined as 2 pi over b, and so since this distance was normally 2 pi, we have to divide it up by 4, because remember our original graph, if this was 2 pi, then halfway was pi. So this distance here would have been pi, and then this distance here would have been halfway there, which was pi over 2, and so on. So we would take our period and divide it by 4 to get these 1, 2, 3, 4 dots. So the x-axis scale is always going to be the period over 4, and that's going to be the distance between our dots along the x-axis. So we're going to use what we know from amplitude and these two new things to find the following. So the amplitude is the absolute value of a, and our a value is 3.5, so it's the absolute value of 3.5, which is just 3.5. The period is 2 pi over b, and in this case our b is 2, so it's 2 pi over 2, or pi. And the x-axis is going to be the distance between our tick marks, our key points along the x-axis, and it's always going to be the period over 4, which is, since the period is pi, it's pi over 4. Okay, in the second example, our a is negative 2.3, so the amplitude is the absolute value of negative 2.3, which is 2.3. From this point forward, you don't actually have to show any of your work. I'm just doing it for future reference. The period is 2 pi over b, our b. So here, if you have x over 2, that's the same thing as 1/2 x. So this value, 1/2, is your b. So I just want to make sure it's clear. You see that? So it's 2 pi over 1/2. Now remember, if you're dividing by a fraction, we're going to instead multiply by the reciprocal of the denominator, which is 2 over 1, which is 4 pi. I do see a lot of algebraic mistakes made in this spot. The x-axis is going to be the period over 4, so the distance between our dots in this graph would be pi. Okay, so let's move on to our graphing. Okay, so here we're going to graph just one period of this one. Here's our function. So the general shape, it's a sine function, so we're just going to sketch it. It starts at the origin, it goes to its max, the origin, the min, and then back to the x-axis. The period is going to be 2 pi over b, and our b is 4. Remember, this is going to affect our amplitude. Our a is 2. So the b is 4, so it's 2 pi over 4, which is pi over 2. So the period is to pi over 2, which means if it starts on the x-axis at the origin, it's going to end at pi over 2. The period is the distance it takes to make one complete wave. So if we need to figure out the x-axis scaling, it's going to be the period over 4, which is pi over 2 over 4, or you can write it as 4 over 1. I do that because I have a fraction divided by a fraction, so I'm going to multiply by the reciprocal, and we get pi over 8. So that means the distance between our dots is going to be pi over 8. So if you think about, if this is 1 pi over 8, this is going to be 2 pi over 8, this is going to be 3 pi over 8, and that's going to be 4 pi over 8. Okay, so we see them marked off here already. And then lastly, we'll find our x-intercepts. So it's a sine function. Sine starts at the origin. It's going to go up to its maximum of 2, since its a is 2. So I'm going to label 2 and minus 2 on my y-axis. So at the first key point, it's going to go up to its maximum. Then at the next key point, it goes to the midline. Next key point, it goes to its minimum, which is minus 2, and then it goes back. So this is going to be one wave of your sine function, or one period of your sine function. I'm going to put arrows on both ends. They should both be pointing up. Remember, we found the period to be pi over 2, which is why this one wave ended at pi over 2. Halfway to pi over 2, when it's at the middle, is pi over 4, because 1/2 of pi over 2 is pi over 4, and halfway to pi over 4 is pi over 8. Pi over 2, 4 times pi over 2 is pi over 8, which is why the x scale, our x-axis, is going to be pi over 8. We can count 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So finally, we can see our x-intercepts. So it's at 0. We have one at pi over 4. We have one at pi over 2. And it's going to continue in this pattern in both directions. Okay, we got another problem. So here we're asked to graph 2 periods of the function. So here we have our a value, so our amplitude is 2.3. That's its distance from the origin. We have x over 4, which is the same thing as 1/4 x. So this 1/4 is my b value. Okay, so it is a negative cosine function. So the general shape is that it starts at its min, goes to its midline, the max, the midline, back to the min. The period is 2 pi over b, which is 2 pi over, my b is 1/4. I'm going to multiply by the reciprocal, which is 8 pi. And my x-axis is always going to be the period over 4, which is 8 pi over 4, which is going to be 2 pi. Okay, so I'm going to graph 2 periods. I'm going to go one to the right and one to the left. Period is 8 pi, and I'm going to deal with this last. So the general shape is starting on the y-axis at its minimum. Its minimum is minus 2.3. So I'm going to go down to minus 2.3, and I'm going to label that. Then the next one is going to reach the middle, and then it's going to go up to its maximum, which I have to label as 2.3, back to the midline, and then back down to its min. And if I continue this, the same U shape is going to go the middle, and the max, and the middle, and then the min. And then now I'll see these two upside down U's, and I'm going to connect with a smooth curve. And then the last thing I'm going to have to do is put arrows on my graph and my x-axis scale. So the period was 8 pi, which means it should end at 8 pi, because one wave is 8 pi, and that is going to be minus 8 pi. Halfway to 8 pi is 4 pi. Halfway to 4 pi is 2 pi. See, the x-axis should, the distance between the points should be 2 pi. Should count 2 pi, 4 pi, 6 pi, minus 2 pi, minus 4 pi, minus 6 pi, and minus 8 pi. I always recommend putting the x-axis scale on last, so that you can write it so that you don't go the graph through what you wrote. Okay, well that is all, and I hope you have a good night.